Okay, boys and girls, here we are, and today we will be collecting data to perform the person composition lab to figure out the percentage of water in copper sulfate. So if you look over here, here are beautiful crystals of copper sulfate, which are blue in color, and that blue color is because they have a lot of water packed inside them. If the water is lost, that same crystals, they will turn into white color, and they will not even keep that nice crystalline shape. They will become like any white colored powder, like a talcum powder. Okay, so let's go ahead and first record the mass of copper sulfate. It's about 2.33 grams. Another thing that we really have to record is the mass of this fancy looking container, which is known as a crucible, which is used to heat solid substances. I'm going to zero my balance and mass the crucible. This would be the mass of the crucible before we started the experiment, 35.51 grams. Okay, now we are going to go ahead and create a heating setup. This is called a ring stand. This is a ring clamp that we put on this ring stand, which is going to hold our crucible in place. If you were to do this lab, it would be a fun, quick lab to do. Here it's a clay triangle which nicely holds the crucible in place like that while we are heating our crucible. This crucible gets really hot, so to move it around, because you will have to mass it later on, you will be using these crucible tongs, and the way you hold it is like this, and then you move your crucible around. Okay, all right. This is our Bunsen burner. I know you have not used it yet. Hopefully someday you'll get a chance to use it. It is connected to the gas, and here I'm using a match to light this Bunsen burner. Before I do that, I'm going to quickly transfer our copper sulfate into this crucible. Remember, our goal is to heat this copper sulfate until all the water is gone. If you're wondering, how will I know water is gone? We are looking for white colored powder, no traces of blue left. And here we go. We turn on the gas. The only time the gas is on is when this lever is parallel to the tubing, and then we light our Bunsen burner. I don't know how well you can see the flame in the video, but here we go. We have started heating it. This is a nice blue flame. If the oxygen supply is not there, it usually is like a yellow colored flame, but we usually set it to a nice blue color because that's the hottest flame. Okay, I'm gonna try to make my crucible stand properly. All right, buddy. Okay, so now we have to let this crucible heat up and the color of the copper sulfate turn to white, which is going to take a little bit time. Are you ready? Yeah. Okay. So, boys and girls, you can see how the blue crystals have almost changed to white powder. I actually see a very, very light trace of blue. I'm trying to break all the crystals and make sure that there is no traces of blue left. Maybe we'll wait for another. You see how it changed from being crystalline to this really white cornstarch and or talcum powder kind of texture. I keep saying talcum powder. I don't even know, you guys, if you know what talcum powder is. Like baby powder, maybe. All right, looks like all the blue is gone. So this is what we're going to do. We're going to turn off the Bunsen burner and let the crucible cool down for 5 minutes. Right, boys and girls? Oh.
Sorry.
Okay, boys and girls, here we are after 5 minutes of cooling. I'm gonna take my crucible carefully. See how I'm holding the crucible with the crucible tongs. I'm gonna put it on the scale. Let's see, what do we have here? 36.98 grams. Please record that value in your data table. That's pretty much the data collection of this for this lab, boys and girls. You need the mass of copper sulfate, mass of empty crucible, and then mass of the crucible after heating. So I just wanted to show you an interesting thing. You see our powder here, which is nice and white in color because it lost water. Let's see what happens if we add little water to it. You see how it turns blue? Isn't it cool? All right, thank you for watching.